Hello, everyone. Thank you for joining today's webinar. This webinar is an introduction to version 3.10 of the ecoinvent database, which we published at the end of November in 2023. I will cover the main data updates that we made, and I will also mention some of the new features. Before we start, let me introduce ourselves. I'm David Fitzgerald, the database operations team lead at ecoinvent. I coordinated the preparation and publication of version 3.10. I'm accompanied today by Tracy Woodley, who is the team lead of the marketing and communication team and has provided support for organizing this webinar. Before we start, I would like to let you know that this webinar will be recorded. We will publish the recording on our YouTube channel in the next weeks. You will all be muted throughout the whole webinar. In case you have any questions, feel free to type your questions in the question window at any time during this webinar. I will answer some of the questions at the end of the presentation. Since this webinar concerns the new content and features of the database, we will prioritize answering questions directly related to these topics. In case of other comments, feel free to use the chat window. Now let's get started. I'll just turn off my webcam and then turn it back on at the end of the presentation. Here's an overview of what I will be talking about today. For those unfamiliar with ecoinvent, I'll first give a quick general introduction about who we are and what the ecoinvent database is. I will then explain what has been updated for version 3.10. I'll be highlighting the main updates that were done for each of the sectors that were changed for version 3.10. And at the end, I will be mentioning a few other updates that concern the whole database. So what is the ecoinvent Association? We are a not-for-profit association based in Switzerland, which was founded 20 years ago by several Swiss research institutions. We actually just celebrated our 20-year anniversary last year. Today, the ecoinvent team comprises over 60 employees. Our main activity is the publication and maintenance of the ecoinvent database, which contains background data on environmental impacts of products and services. Our mission is to promote and support the availability of high-quality data. We achieve this by compiling and reviewing the best available data and publishing it in the most transparent way possible. The data published in the ecoinvent database can be used for supporting all kinds of environmental studies. The ecoinvent database contains data that model the average inputs and outputs of human activities, covering a wide range of products and services. We work with a variety of data providers from various organizations, such as research institutions and industry associations. Before we publish the data, we make it go through a review process to ensure that it complies with ecoinvent's data quality requirements. There are tens of thousands of users that use the ecoinvent database in over 80 countries. They either access the data directly through our website or use it through softwares and other tools. Finally, the database is compliant with the ISO 14 series. Here's an overview of the main sectors for which data is available in the ecoinvent database. As of version 3.10, the database contains over 20,000 datasets that model different steps of the supply chains of products and services in the sectors depicted here. Let's dive now into the main topic of today's webinar and see what were the main data updates done for version 3.10. The updates done for version 3.10 concern mainly the 9 sectors listed here. The most significant changes were made in the sectors for oil and natural gas, chemicals, electricity, and waste. I'll spend a bit more time on those sectors, in particular oil and gas and the chemicals, and then describe more briefly the updates done in the other sectors. And at the end, I'll cover the few other updates that are not specific to a sector, as well as some of the features available to our users. Before diving into each of the sectors that were updated, I would like to give you an idea of the scale of the changes done for version 3.10. What you can see here is a graph showing the numbers of datasets in version 3.9.1 and in version 3.10 in each sector. The dark blue bars represent the numbers in version 391, while the numbers of new datasets are indicated in light green. And in dark green are the datasets that were available in 391 but were updated for version 310. We can see that for the sectors for agriculture, chemicals, fuels, and waste treatment, we have added quite a few new datasets. And we will see later on why the number of new datasets is so high for the waste treatment sector. We have updated datasets in all sectors, but we can see that the sectors for chemicals, electricity, fuels, and waste have more updated datasets compared to the other sectors. The first sector I would like to cover is the one for oil and natural gas. The update done for version 310 builds on top of the major update made for 391. Basically, the modeling of the whole sector has stayed the same as how it was set up for version 3.9, but it has been updated based on the most recent statistical data available. The data are for the year 2021, meaning that they do not yet reflect the changes that occurred since the war in Ukraine has started. What is shown on the map on this slide is the geographical coverage of the datasets that model the extraction of petroleum and natural gas. We have introduced data for additional countries. Version 310 covers the production of petroleum and natural gas in 41 countries, while 27 countries were covered in version 391. As indicated in the table, over 95% of the world production is represented for petroleum and natural gas as of version 310. In the extraction activities, the main data points that differ from one country to another include emissions of methane, gas flaring, energy requirements, production volumes, and infrastructure inputs. In terms of modeling changes in these activities compared to version 3.9, the main changes concern how the water balance and discharge of produced water are modeled, as well as the modeling of bore well infrastructure. For version 310, the modeling of the water flows is based on regional factors published by the International Association of Oil and Gas Producers. In addition to the datasets for the extraction of oil and natural gas, we have also increased the coverage of the datasets modeling the export of liquefied natural gas. We have increased the number of countries from 9 in version 3.9 to 14 in version 3.10. With this update, we now cover 93% of the exports of liquefied natural gas. Regarding the distribution of petroleum and natural gas, we have increased the number of markets available. For petroleum, we have added markets for 5 countries, and for high-pressure natural gas, we have added 13 countries. The outcome of this update is that roughly 90% of the global consumption of natural gas is covered by country-specific market mixes, and we now also cover more countries in Asia. For the markets for natural gas at high pressure, as the map shows, most of the data comes from the global energy statistics published by BP. For European countries, data is either taken from Eurostat or national statistics for a couple of cases. We have also slightly increased the number of markets for local distribution of natural gas, meaning natural gas at low pressure. There are now markets for 15 countries in version 310. The update of this sector was provided by ISO Services, who had already provided the update for version 3.9. For this update, they relied on the most recent versions of the main data sources available at the time of data preparation. These are the sources listed here. For more details about this update, you may refer to the report published on ISO Services' website, which you can find by using the URL shown here. Still in the fuel sector, for version 310, we have introduced new datasets that model the production of coke in China through 2 different technologies, wet quenching and dry quenching. In addition, the reservoir dataset for coke production was revised. The reservoir dataset in version 310 now represents a weighted average of the datasets in China, Germany, and the US. We also updated the rest of the world market so that it is supplied by the different production data sets outside China, as well as the Chinese market for coke. With this update, the global warming potential score of the rest of the world market is 50% higher than the score of the global market that was available in version 391. This is mainly due to the remodeling of the rest of the world coke production dataset, which now represents a weighted average of the different technologies that are known to be used, while the dataset in version 391 was based only on data from the US. For the chemical sector, we made several major updates for version 310, which I'll be covering in the next slides. One of the main updates concerns the supply chain of hydrogen, which we have completely revised. There are now two different products that model hydrogen, both in gaseous states, low pressure hydrogen and medium pressure hydrogen. The low pressure hydrogen represents hydrogen at around 25 bar, which is considered to be used on site or in close vicinity to the production facility. The product medium pressure hydrogen represents hydrogen that is ready for transportation at 200 bar. In version 310, there are two main production technologies for hydrogen. The first is steam methane reforming, which was already present in version 391, but has been updated for version 310. For that production route, datasets modeling production in China and the US were introduced, while only Europe and the rest of the world were available back in version 391. The second main production technology is coal gasification, which is a brand new activity that was added in version 310 for China, the US, and the rest of the world. For both technologies, the hydrogen is produced at low pressure. For version 310, we have also introduced a new dataset that models the compression of hydrogen from low pressure to medium pressure. We have also added and updated activities that produce hydrogen as byproduct. One new activity in version 310 is the activity modeling stream cracking. It produces low pressure hydrogen as byproduct alongside other products. Also worth mentioning are the activities for chloralkali electrolysis, which have been updated for version 310 for the geography covering Europe. The production of hydrogen from coal and natural gas contributed to approximately 93% of the global output in 2020, with half being produced in China, United States, and Europe. So this means that the main production routes of hydrogen are modeled based on the data that we now have available in this latest version of the database. The outcome of this update is that the impact scores of the markets of hydrogen have increased significantly in comparison to version 391. And this, of course, also affects processes downstream that consume these hydrogen products. One of the major updates for version 310 concerns the replacement of datasets modeling the production of olefins and aromatics. As you might know, light olefins and monocyclic aromatics are essential raw materials used in the production of a wide range of chemicals and plastics, which are then used in manufactured goods in various industries. In previous versions of the database, the production of these products was modeled with old aggregated lifecycle inventory datasets, which meant that those datasets were, for example, not connected to the oil and gas supply chain that is modeled in ecoinvent. This has changed for version 310. We have introduced the activities shown in the diagram presented here, with the exception of the petroleum refinery operation indicated in the lower left corner, which was already present in previous versions of the database. For the sake of simplicity, the intermediate products are not shown on this diagram. What you can see are all the final outputs of the different activities. You can find a more detailed version of this diagram in the report of changes. The main point I want to highlight here is that the inputs to these processes are supplied by other datasets in the database, which includes the updated oil and gas supply chain further upstream. So this means with this update, the value chains of the different products listed here are modeled more transparently than in previous versions. This update has resulted in an increase of the global warming potential scores of several products. This concerns in particular the markets for butadiene and propylene, for which the scores roughly doubled for the rest of the world markets. The global warming potential scores for the ethylene products have increased by roughly 50%. And naturally, these changes in scores affect the consumers of these products. Regarding the origin of the data comes in large part from the industry in Europe and was complemented with the literature data. The industry data was provided by Plastics Europe and prepared with the support of EFOI. With the exception of propane dehydrogenation, the European datasets are representative of at least 80% of the European production. The primary data for the steam cracking dataset are from the years 2018 and 2019. The data for the BTX extraction are based on the year 2012, as well as literature data from 2017 and earlier. Finally, the production of ethylene oxide, ethylene glycol, and propylene via propane dehydrogenation are based on literature. In the context of this update, the rest of the world datasets that were previously available have been updating by recontextualizing the new European data. This way, the old aggregated lifecycle inventories are completely removed from the database for all geographies. This obviously increases the transparency of the supply chains of these products. Another update done in the chemical sector concerns the supply chain of methanol. Methanol is produced mainly from natural gas or coal, and these two main production routes are now covered in version 3.10. The production through natural gas reforming was already present in version 3.9, but we have updated it for version 3.10. Datasets are available for China, the US, Europe, and rest of the world based on data published in literature in 2017. The activity for the production of methanol by coal gasification is brand new. China is the primary supply of coal-based methanol. So for this reason, we introduced datasets only for China and rest of the world. For version 3.10, we have also introduced datasets that model the production of light olefins from methanol, such as ethylene and propylene. Such facilities operate in China and use high shares of coal-based methanol. The data for these new activities are based on process data and estimates from literature data for the years 2014 to 2021. Since China is the main country where such operations take place, production datasets were only added for China. Another update performed in the chemical sector concerns the datasets modeling the chlor-alkali electrolysis, which produces chlorine and sodium hydroxide. A dataset representing the average European chlor-alkali operations was added for version 3.10 based on data provided by Eurochlor, which is the Association of Chlor-alkali Plant Operators in Europe. This new dataset contains average data for the membrane and diaphragm technologies. The data are representative of 75% of the European capacity of chlor-alkali electrolysis. The dataset modeling the membrane cell process was also kept. However, the European dataset modeling the mercury cell process was deleted as that technology has been phased out. And the European dataset for the diaphragm cell process has also been removed as it is included in the new averaged activity. The rest of the world, the activities that were previously derived from the European datasets have been updated by recontextualizing the new European data. As these datasets model the production of sodium hypochlorite, the datasets for sodium hypochlorite production that were available in previous versions of the database have been removed for version 3.10. Another interesting update done in the chemical sector concerns the production of diisocyanate and polyols. Polyols, MDI and TDI are the main building blocks for polyurethane, which is used in a wide variety of applications. Previous versions of the database already contained a dataset for modeling the production of polyol, but it was an aggregated lifecycle inventory. For version 3.10, we have replaced it by two activities that produce short chain and long chain polyols. And we have updated the datasets for the production of MDI and TDI in Europe. This data comes from the industry. It was provided by ESOPA, which is the European Trade Association for producers of diisocyanate and polyols. The data represents 80% of the European production volume of polyols and 100% for the MDI and TDI. So this means the datasets in version 3.10 represent the most up-to-date available data for these production processes in Europe. The rest of our datasets were also updated based on this data, since they were previously based on the old European datasets. In addition to the new and updated unit process data, we have also added datasets that contain the eco profiles that were published by ESOPA for these products. These eco profiles are aggregated lifecycle inventories and were not calculated with the ecoinvent database in the background. They were also created using different allocation rules than those applied in the ecoinvent database. So these eco profiles can be interesting for users who would like to use the data as it was published by ESOPA. They, however, do not supply other datasets in the ecoinvent database, since the updated unit processes are used for that purpose instead. Here are the last updates I would like to mention regarding the chemical sector. We have introduced several datasets that model the supply of cooling energy at temperatures well below ambient. On top of that, the datasets for around 20 chemicals were updated based on literature data and stoichiometric calculations to improve the modeling of those reactions. The mass inputs and outputs were updated either partially or entirely based on a generic model. And the data generated by this model were improved when possible with industry or literature data, in particular for the energy inputs. Finally, in over 400 datasets that model the production of chemicals, some proxy exchanges are used for modeling flows such as energy inputs, infrastructure, and water flows, among others. The way these proxy exchanges are used has been harmonized for version 3.10 to ensure a consistent modeling throughout the chemical sector. As is usually the case with every update of the ecoinvent database, we have updated all electricity market mixes. This update was carried out in collaboration with ETH Zurich and the Paul Scherrer Institute. As was the case in previous versions, the markets in ecoinvent represent 100% of the statistically reported data for electricity supply. This means only a few very small countries and some island states are not represented in the database. For version 3.10, the market mixes for China, India, Brazil, and Switzerland were updated based on national statistics for the year 2021. For the other countries, the data is based on statistics published by the International Energy Agency for the year 2020, except for the US and Canada, for which data for 2021 was available when the update was performed. This update caused changes in impact scores for global warming potential, which are between plus and minus 10% for most markets. The changes are in some cases a bit more significant, particularly for markets for some small countries. Apart from updating the market mixes for all datasets that model electricity markets, transformation and import activities, we updated the reference year wherever it was mentioned in the metadata fields, just to make sure that the year mentioned corresponds to the year of the statistical data. In the electricity sector, we also updated the European electricity residual mixes that we had introduced for version 3.9. These mixes represent mixes of untracked electricity consumption, meaning electricity that is not tracked through reliable tracking mechanisms such as guarantees of origin. In version 3.10, there are no residual mixes for Austria, Ireland, and Switzerland, as these countries fully disclose the origin of all their electricity consumption. The data is based on statistics from the Association of Issuing Bodies. And lastly, we also introduced data sets that model the production of small-scale wind turbines in Germany. Another significant update for version 3.10 concerns the restructuring of the waste sector. With the previous modeling approach for waste treatment, the final fate of a waste and all the waste being generated throughout the different treatment steps were modeled in one single dataset. This is what is depicted in the box on the left on this slide. The old modeling approach was limited in terms of what could be easily customized by the user. Also, no transport was accounted for between the different treatment steps in the supply chain. Now in version 3.10, intermediate wastes produced by different waste treatment steps have their treatment modeled in separate processes. Markets have been added between the different intermediate treatment steps so as to account for the collection and transportation of those wastes. Although for the sake of simplicity, the markets are not shown in the diagram presented here on the right-hand side. With this new approach, transparency is increased since intermediate wastes are explicitly modeled. This means that the treatment chain can be analyzed in more detail and can also be optimized. It also enables users to more easily adapt waste treatment chains to their specific situation if they desire to do so. This disaggregation of treatment chains has been done for wastewater for version 3.9. And for version 3.10, the treatment chains for all other wastes have been disaggregated. This resulted in many datasets being added, so this explains why the number of new datasets is so high for the waste sector for version 3.10. We have two main updates for the agricultural sector. For Australia, we have added datasets that model the production of 5 crops. These new crop datasets are modeled for specific states, for example, Queensland, Tasmania, and Victoria, just to mention a few. We also introduced datasets modeling 5 types of field operations, which are available at the country level. The second major update concerns data for the United States. We have also introduced new regionalized data, in this case for 4 different crops for many states in the US. Those 4 crops were previously only modeled at the level of the country. On top of that, 41 datasets that model field operations were also added, in this case at the country level. For version 3.10, we have also added new data for flax production in Europe. There are 3 products available: flax straw and short and long flax fibers. These data were provided by the Alliance for European Flax, Linen and Hemp. Last point I would like to mention for this sector concerns a new file that we have made available in our database. This file contains the values of greenhouse gas emissions related to forest, land, and agriculture. These emissions are referred to as flag emissions. Since agricultural datasets in ecoinvent account for most of the emission sources mentioned in the flag guidance, the file contains land use change related emissions values for all agricultural datasets contained in the database. This file covers agricultural datasets that already have land use change modeled in the database, as well as datasets that do not yet have land use change modeled. This file can support users who are interested in setting science-based targets for flag-related greenhouse gas emissions. You may download the file by accessing our database through our website and then going to the file section. You can find it among the supporting documents of version 3.10. And here's a small snippet of what you can find in that file. You can see here a few rows. We're showing different data sets that model crop production. And in the blue columns on the right side, we can see the emission amounts of the different emissions that contribute to flag emissions. We have several updates in the construction sector. To summarize these different updates, we have basically either added or updated data for specific countries, meaning that we have improved the geographical coverage for this sector. The first one concerns data for construction materials in Tunisia, which was a country that was not covered so far in the database. The data was collected in 2019 and covers clinker production as well as the production of 3 types of cement produced in Tunisia. For version 3.10, we have also updated cement and clinker datasets for Switzerland based on data from 2017 to 2021. This update covers clinker and different types of cement. In the context of this update, several types of cement that are no longer produced in Switzerland have been removed from the database. The data was provided by SEM Swiss, which is the Swiss Cement Association. And the data is based on the national average of all cement producers in Switzerland. For version 3.10, we introduced a variety of new products related to the construction sector in Ecuador. The new data cover the production of clinker, cement, and concrete block. We also obtained data for artisanal construction materials, which include adobe bricks, clay bricks, for which 2 different production technologies are available. Data for clay tiles was also added and includes both glazed and unglazed tiles. In addition to the construction materials, we also added data for bamboo products in Ecuador. The data covers bamboo culm, which is the product of bamboo cultivation, and we have also data for the production of bamboo poles and flattened bamboo. These bamboo products were already available in the database for other countries. For these other countries, we have updated the production volumes for version 3.10. The data for both the construction materials and bamboo products were provided by EMPA, based in Switzerland, in cooperation with the Inclusive Circular Economy and Sustainable Development Research Group of the University of Cuenca, based in Ecuador, and with the support of the Swiss Agency for Development and Cooperation. We have a couple of updates worth mentioning for the pulp and paper sector. The first concerns an update of the datasets that model the production of containerboard and corrugated board box. The data comes from European producers and was collected by FEFCO, which is the European Federation of Corrugated Board Manufacturers, and CCB, which is the CEPI containerboard. The data is from 2020 and covers from 70 to over 80% of European production, depending on the product. The data collection was done in collaboration with RISE, which is the Research Institutes of Sweden, and it was reviewed by IFOI. In addition to the update of the European datasets, the datasets for Quebec and the rest of the world were updated in the cases where they were extrapolated from the old European datasets. The second update concerns new datasets for beverage carton production for 3 types of liquids, which include UHT milk, fresh milk, and juice. The datasets are based on an LCA study on beverage cartons in the European market, which was conducted by IFOI. The data for that study is from 2017 and was provided by the members of ACE, which is the Alliance for Beverage Cartons and the Environment. And now the last sector I would like to mention, the metal sector. For this sector, through a collaboration with the University of Barcelona, we have introduced datasets that model the application of a surface coating by thermal spraying. 3 different types of thermal spraying are available, as well as the preparation of the workpiece by abrasive blasting. Another update I would like to mention is the update of prices of rare earth oxides. This update was done in order to have all prices of rare earth oxides based on the same source. This way, we have a more reliable representation of the ratios of prices between the different rare earth oxides. This update has led to a change in economic allocation factors in the cases where economic allocation is applied on those products. Now moving on to other updates done on the database for version 3.10. For this new version, we have assigned CAS numbers to all products and elementary exchanges that represent chemical compounds. And we have also introduced a new classification for products, the HS 2017 classification system. You may find it, for example, in one of the Excel files that is available on our website. The database overview file contains a list of all datasets available in the database. And in that file, you can find the HS classification alongside other classifications. And you can use those different classifications to more easily filter for products that are available in the database. With version 3.10, we have made some updates to the impact assessment methods. We have added the methods listed here. The footprint version of Impact World Plus is a reduced version of that method with a handful of indicators that cover different impact categories. The U-stocks methods have been updated to the latest version available. And then we have an update regarding the inventory results and indicators, which replaces what was previously named selected LCI results. It's not an actual impact assessment methods per se. It simply sums up the lifecycle inventory amounts of certain elementary flows. Finally, we have introduced a new indicator for global warming potential, specifically for the system model that is compliant with the EN 15804 standard. This new indicator has been defined such that it is aligned with the new version of EPD product category rules for construction products. I also want to mention that we have updated the EcoQuery web interface last year. EcoQuery is the online platform that is accessible through our website and which allows you to search for data in the database. With this new version of EcoQuery, you can, for example, browse the database using an updated search engine. You may also access detailed information for each dataset, including, for example, metadata and impact scores. You can more easily explore supply chains within the database compared to the previous version of EcoQuery. And you can also access a variety of supporting files, such as LCI scores in Excel format, or for example, the file I showed earlier that contains the flag emissions for agricultural datasets. Anyone with a valid ecoinvent license can use the EcoQuery interface, also if you have purchased ecoinvent through a software provider. And since we have recently published this new version of EcoQuery, we'd be very happy to get your feedback about this new version of the platform. So feel free to send us any suggestions or suggestions for improvements. Last thing I want to mention is that you can find more detailed information about version 3.10 on our website. Here's the URL of the page dedicated to version 3.10. You can find useful files there, such as the database overview Excel file that I mentioned earlier. But most importantly, you can find the report of changes, which describes in more detail the updates done for version 3.10. So many updates that I did not have time to mention today, as well as the updates I mentioned today, but for which you might want to get more details. For all these, you may find more information in that report. With that, I have covered everything I wanted to mention about version 3.10. Before I answer some questions, I'd like to remind you that you are always welcome to contact us in case of questions and comments or feedback. You may do that through the URL shown here. And also, if you have data that you think would be an interesting addition to the database, please get in touch with us. We rely on data providers for updating the database every year. So if you have any data that you think would be a good addition to the database, please contact us. So the answer is yes. So for most plastics and chemicals that we have in the database, they do connect now as of version 3.10 to the supply chain of oil and natural gas. So that is one of the big changes for version 3.10. So the way we update prices is we don't update all prices every year. We focus on the prices of products that are being produced by the new datasets or by datasets that we are updating. So it means that for those products, we will, if we see that it's relevant, so meaning if, for example, if economic allocation is being applied, we will update the prices for those products. Yes, so we have in the supporting files, one of the files available there is a file showing the scope 2 and 3 emission factors for the electricity sector. And so this is available when you connect to the database through the ecoquery interface. So where you can look for the source is, first of all, the report of changes. So for the version 3.10, you will find in there a short explanation and also a mention of the sources for this price data. And in general, you may look at the properties of the different products. So if you open a data set in ecoquery, go to the reference product and then look at the details, which will show you the properties. You will find among the properties the price, and the price has a comment that contains more information about where the price comes from. So yes, we have that available. It's one of the supporting documents that you can access directly on the website. It's called the correspondence file. And what it shows is for each system model that we publish, a mapping between the datasets of the old version and the new version. So this is useful for users who are switching between different versions of the database. It might support you in doing that. So actually that file only covers emissions related to land use change. That's the focus of that file. You can then refer to the lifecycle inventory for other emissions. The answer is yes, we haven't removed that system model. However, if you have been using ecoinvent in CIMAPRO, we know that for version 3.9, 3.9.1, the APA system model was not published, but it will be available to users of CIMAPRO for version 3.10. Yes, so for the electronic sector, it's very difficult to get data. We are working on it, but at this stage, I cannot yet say when an update will be available for that sector. So if you want any more details for that update and for other updates in general, I would recommend going into the report of changes. You'll find more details there, as well as in the metadata of the datasets themselves. The answer is that file currently covers agricultural products. It will be extended in the future, potentially for the next version already, to cover other datasets in the database. But for now, it's focusing on the crops. For the time being, we don't have ongoing projects for packaging. We are focusing a bit more on commodities that are further up the supply chain. So for version 3.10, the update for the waste treatment sector focused just on disaggregating the existing chains. So there hasn't been the addition of more types of plastics. So these are what we commonly refer to as the undefined datasets, which show the unit processes before allocation is applied. And they are actually available in ecoquery, but the way you can access them is a bit different compared to the old version. You have to now open the dataset in a system model, and then in the export tab, which contains a few files related to that dataset, you will find there a PDF file which shows the data set as it is before allocation. And so you will find not only the quantitative data, so the amount of the inputs and outputs before allocation, but also the different metadata. So whenever you look at the life cycle inventory or the life cycle impact assessment scores, so the LCIA scores, these are always from the cradle. So whatever is happening along the supply chain is reflected in the life cycle inventories, and then as a consequence of that, also in the life cycle impact assessment scores. The only thing is when you look at the unit process version of the data set, this will only show you the direct inputs and outputs in the last step of the supply chain. The main reason was to provide more detail and in particular explicitly model the different waste that are generated during the treatment of the waste, the first waste that comes out of different supply chains. In this way, like it allows users to see more detail, like identify the hotspots along the treatment chain. And if users want to customize the treatment chain, they can also do that more easily with the new version of the modeling of the waste treatment sector. There are still some questions that were not answered. You will be able to find answers to these questions via our website on the page related to version 3.10. With this, thank you for your attention and for watching this webinar. As mentioned before, we'd be happy to get your feedback regarding the database, so feel free to get in touch with us. Have a nice day. Bye-bye.